Hello friends, welcome to JavaFx 3D tutorial. In this video, we will look at scale transformation. So in the previous two videos, we talked about translate as well as rotate. And when we are talking about rotate, we discussed about pivot point. And now we will explore how to work with scale transformation. So we can perform scaling in all three axes just like rotate. So for this example, we need to depend on the 3D object. So that's why we are creating a box, and using this box, we will explore the scale transformation. So in the last video, we talked about rotate transformation. Now we will continue with the scale transformation. In JavaFx, scale transformation expands or shrinks the coordinate system in X, Y, Z axis. Node points are mapped to this scaled or shrinked coordinate space. So in all transformation, if you see, the coordinate space undergoes the transformation, then performs the drawing based on layout X and layout Y, and after performing the drawing, the coordinate space return back to local coordinate space. So there are two coordinate space. One is local and another one is transformed coordinate space. The transformed coordinate space is temporary, and after the drawing, the transformed coordinate space goes back to the local coordinate space. So the transformed coordinate space is what called the new coordinate space or temporary coordinate space, and in which the drawing will be performed, and we call that as the mapped plotting. Alright, so node points are mapped to this scaled or shrinked coordinate space, and if you want to see that here, so this is the origin, and you can see the unit here. Let's state that this is our box, but we will be viewing it in the XY plane. So you will be seeing a rectangle and 1, 2, 3, 4 point, or we will just take 3 point, 1, 2, 3, or 4 point, and here it is 2 point. Let's take like this. So this will be the initial rectangle. Let's assume each is 1 unit. One from here we are starting, right? 1, 2, 3, 4 unit. So rectangle width is 4 unit and height is 2 units. Right. So let's assume that we are scaling the object using the coordinate transformation, and we scale the object in 2x, and we apply this 2x on x, y as well as z, but z we cannot see, and xy we will take it, and it is 2x, right? So what happens in coordinate transformation? We are asking to scale it 2 times. That means 1 unit becomes 2 unit. So this is our new coordinate. So I made a small mistake here, but that's okay. Let's assume here also it got expanded. So if you see, 1 unit is expanded as 2 unit. The same happens here. Here also we will take from here since we made a mistake there. So this is the expanded coordinate space, and what we want to draw is a 4 unit. 4 unit now is, this is 1, 2, 3, 4 units in the transformed coordinate, and a 2 unit here. And if you see, the object is drawn in the transformed coordinate, and after drawing, so let's state that this is the dimension of the box, and after drawing it, the coordinate space will return back to the local, the blue colored one, and you can see the old object is scaled to the new one. So what happens here, based on the dimension, so if we specify top, left, width and height, those will be plotted against this new transformed coordinate, or we can say scaled coordinate, and object is drawn, then coordinate return back to the local system. So if we specify 0.5x, then the coordinate will be shrinked. That means this is the previous unit, right? The shrinked unit will be, shrinked, and if you see, each 1 unit is further divided here, and the rectangle will be drawn like this. It will be diminished in size. So this is 0.5x. This one is the real one, and this is 2x. So this is how you can scale as well as shrink, and that's how JavaFx performs the scale transformation. As like other two transformations in the sense, the translate as well as rotate, which we discussed in the previous 2 videos, we can use scale class to apply the transformation, or you can apply the transformation using the properties scale x, scale y as well as scale z properties. So far we discussed about 3 classes to perform transformation. One is translate, another one is rotate or scale. So these are all the special classes. Or you can make use of the properties like translate x, translate y, translate z, rotate x, rotate y, rotate z. That's to specify the rotation axis, or pivot x, pivot y, pivot z. The same way here we tell scale x, scale y, scale z, and perform the scale. The scale transformation can also be applied on pivot point, and in this video we will draw a 3D box and apply the scale transformation on each axis. So this time we create a 3D shape box, and this is width, height and depth. So we will perform scaling on all 3 dimensions, and for this box we apply a material to see a color. Since it's a 3D shape, we need a material, so we create a form material and we set a color of orange to this box. So box dot set material, red material, we are setting the material to the box. Then we get children to our root and we add this box. So now box is added to the scene graph, and when you run it will look like this. Why? Because this is the x and this one will be the y, and z is towards u, and so it will be pointing towards you. So you are seeing through the z-axis, that's why you are not able to see the depth. You can see 350, so this is 50 and this one is 300. The other side we are not able to see because of the orientation, so the box is oriented towards our eye. For that we perform the rotation. So here we make use of box dot set rotation axis, and the rotation axis we give a 3D point 1 1 1. So that means we want to rotate it on XYZ. Rotation axis we specify it based on the point 3D, and when this point 3D contains all 1, that means we want to rotate in XYZ. So the first one is X, second one is Y, and third one is Z. So if you specify only these two, and if you specify 40 degree, the box will be rotated about X-axis as well as Y-axis. So 40 degree in X, 40 degree in Y. Here in this case, if you see, the box will be rotated about X-axis 40 degree. About this, it will be rotated 40 degree. Then about Y, it will get rotated 40 degree, and about Z, it will be rotated 40 degree. So all three rotation takes place with the set rotate method. Here if you see, the object is rotated in all three axes. That's why you are seeing the initially here in this picture you saw only this specific face. Since we rotated this in 40 degree in X as well as Y, we are seeing both the faces. So this is the top face and this one is the side, right? So now we see all three faces. This will help in scaling the object and see how it is magnifying. So box dot set scale 1.5. So along the X direction, on this direction, we are making the coordinate shift. So 1 unit goes to 1.5 unit. So here the magnification will go further. And if you see, the box is extended in X direction, right? In X direction it got extended, and other are same. So this is Z. So this one is the Y, this is X, this is Y, and this one is Z. Right, so 3 dimension X, Y, Z, X, and this one is Y, Z. YZ. All right, so but we applied scaling on X direction only. That's why you are seeing the box is extended in X direction. Next, we set scale on Y axis and we are extending it to 1.5. So Y, if you see this one, this is the height of the box, and you can see the height got increased now. So this is the height, right? So in Y we specified the height and that got increased. Finally we set scale on Z also. What happens? So this is 0.25 maybe. So in Z direction this becomes thin. So we already scaled the Y, we increased the X but compressed the Z. So the box becomes a slab here. So this is the Z direction, right? In Z direction we compressed it. So here it is wrong, 1.5, but maybe we gave 0.2 or 0.25 to reduce the thickness or depth to almost 0.2 just by looking at the picture. Alright, that's all here. Now we will go to demo and see how it works. So this is where we left previously. We will remove this. We will copy rotate transformation and do a refactor paste. scale transformation, refactor it. Just cleaning up the code for previous example. So here we created a stack pane, prepared the skin, we set title, then we are creating the box, assigning a material, and we are displaying that, or we are assigning that to the root. Box, material assigned, box added to the root, and the root is already given to the scene. Right, scene is constructed based on this root, and the stage is displayed. Start pane, scene, so we took code from a rotate transformation. We will rename this as a scale transformation. We will change it as 800 class 600. Box is from JavaFx scene shape, Pong material, JavaFx scene paint color, and material is from JavaFx scene Pong material. Save this. Let's rebuild once and see box is showing up. So this is our box, and we need to rotate it to see other faces. So here we are performing the rotation in all three axes. Alright, now let's build this. And you can see the box is rotated, and you can see all three faces. So this is on XY plane, this is on XZ plane, and this is on YZ plane. So there are three faces. Now we will perform the scaling, and we will see how the scaling takes place by commenting the Y and Z. We will do a quick runs here, and you can see the X is expanded. Here Y is also expanded from our previous. Now we will expand the Z also to 1.5, then we will compress it. First let's expand. So if you see, in Z also it got increased. Now we will make it as 0.2. We'll run this, and you can see how the depth is diminished, and you can see in Z direction the coordinate is compressed, and the slab becomes, the box becomes a slab because the depth is reduced. Right, that's all here on scale transformation. Thank you for watching. Bye.